acceleration is the derivative of velocity. And recall that, so this is the notation for derivative, d dt. That means derivative with respect to time. And then in this case, we have the velocity instead of the position. So velocity was the derivative of position, acceleration is the derivative of velocity. Everything we learned about the derivative is the same. You just take it with respect to the velocity versus time graph rather than a position versus time graph. The derivative is defined as the limit as the time interval gets really, really small of the change in the thing you want to take the derivative of, in this case velocity, divided by the time interval. This quantity is exactly equal to the average acceleration. So it is completely worth defining the average acceleration, if for no other reason than it's part of the definition of the instantaneous acceleration, because it appears in the limit expression. All of the units first. So I'm drawing vector arrows over everything. Acceleration is also a vector, probably not surprising. Position, velocity, and acceleration are all vectors. And the units for acceleration come from the expression of velocity over time. They both have the same velocity over time in both expressions. If the units for velocity are meters per second, then there is another second on the bottom because you're dividing by time. So the units for acceleration are meters per second squared. It's a vector and has units of meters per second squared. Everything else that we learned about derivatives when it was velocity as a derivative of position still hold true. So the acceleration is a derivative of velocity with respect to time. That also means it's the slope of the tangent line, velocity versus time graph. Wrong place to put the vector arrow. It's the slope of the velocity versus time graph. It's the first derivative. Another way to say it is also, you could say it's the time rate of change of velocity with respect. 3 different ways to say the same thing, and 3 different ways that you might want to calculate the same thing. So if you like these analogies, acceleration is to velocity in the same way that velocity is to position. So everything we learned about taking derivatives, finding the slopes, all of that translates exactly from finding velocity from position to finding acceleration from velocity.